All right, so let's run through part A real quick. Part A just wants us to find f prime of 4. F prime of 4 will approximate that since we're giving values of f of x by just looking for the average rate of change between 3 and 5. So we'll do negative 2 minus 4 over 5 minus 3, which would be negative 6 over 2, or negative 3. So that should be one easy point there. Everybody good with part A? Part B, we're going to integrate from 2 to 13, 3 minus 5f prime of x. So for part B, what's the integral of 3 minus 5f prime of x? Well, it's 3x minus 5 f of x, right? Integral of f prime is f, 5 is a constant, and multiplied by it, and then the 3 turns into 3x from 2 to 13. Everybody good with that? Which should be 39 minus 5 f of 13 minus 6 minus 5f of 2. And let's see, looks like that will come out to be what? 39 minus, we got 39 minus 6, which is 33. And then we got minus 5 times 6, that's f of 13. And then we got minus a negative, so we got plus 5 times f of 2, which is 1. So we got 33 minus 30 is 3, plus the 5 gives us 8. So 1 point if you successfully got these f of 13, f of 2 values, and 1 point for the final answer. Everybody good there with part B? All right, part C. We're going to use a left Riemann sum to approximate the integral from 2 to 13 of f of x. So we're going to use the data in the table. We have unequal subintervals here, and interval of 1, 2, 3, and 5. So we have to do each one separately. So the first one has a length of 1 and a height of 1. The second one has a length of 2 and a height of 4. The next one has a length of 3 and a height of negative 2. And the last one has a length of 5 with a height of 3. And that gives us 1 plus 8 is 9, minus 6 is 3, plus 15 is 18. And that was worth 2 points, 1 for correctly setting up your sum, 1 for your final answer. Everybody good with C? All right, part D then. Shouldn't be too bad, but it's good refresher, I think, for us. We've got f prime of 5 is 3, and f double prime of x is less than 0. We're going to use the tangent line to show a bunch of stuff. So first off, we're going to use the tangent line to show a bunch of stuff. We probably need to find the tangent line at the value they're asking. So we want to find the tangent line at x equals 5. So that's going to be from the point 5, negative 2, and I already forgot what was the slope. The slope was 3. All right, so our tangent line equation, we should end up with y minus negative 2 equals 3 times x minus 5, which is good, or if you want to distribute it through, you're welcome to distribute it through and all that. Y equals negative 2 plus 3 times x minus 5, or if you want to simplify it all the way, what is that, 3x minus 17, it looks like. Any of those are fine. This is the one they put on their answer key, but like I said, any of them are fine. So then what does it ask us to do with that? It says, show that f of 7 is less than or equal to 4 using the tangent line. So we know that our function is concave down. And so if our function is concave down, that means the tangent line should be an overestimate. So if we were to approximate the value at 7 using our tangent line approximation, y of 7 should be 4, and therefore f of 7 must be less than 4 because it's concave down. Good or no? Everybody good with that first part of part D? And then the second part asks us to use the secant line from 5 to 8. So if we're going to use the secant line from 5 to 8, that means we need the 0.5, -2, and we need the 0.8, 3. Find the slope between those, 3 minus -2 over 8 minus 5 to be 5/3. And so now our equation ought to be y. You can use either one you want. I'll use 8/3. Y minus 3 equals 5/3 times x minus 8. Or if you prefer, y equals 3 plus 5/3 of x minus 8, or if you prefer, distribute it all out. Everybody good with that? And then we're going to approximate that at 7. So at x equals 7, that becomes 3 minus 5/3, which is 4/3. And so for a secant line, our approximation should always be under if the function is concave down. So therefore, f of 7 must be greater than the value we got from the secant line, which was 4/3, for the same reason that the function is concave down. Any questions there on part D? It was 1 point for the tangent line, 1 point for the secant line, 1 point for all of this work, and 1 point for all of this work and the explanation. I think it's a good refresher that if a function is concave down, the tangent line on the interval will be an overestimate and the secant line will be an underestimate, and vice versa. If it's concave up, we'll flip those around, and tangent line will be an underestimate and the secant line will be an overestimate. Everybody good there? You're all very quiet. Did you all just get 9 out of 9 on that? Like it was nothing, no problem, easy? Why am I wasting your time with it? Let's see. All right, let's do. We did that one. Let's do this one. So I'll give you guys 15 minutes here to work through this one. And then looks like we'll have to go through that one tomorrow. So we'll go through this one tomorrow right before the quiz.